All right, so we're going to focus on problem 25.6 out of the book. We're going to do that as an example problem. I want to make sure you guys get the value of your book. And we're going to tackle the parabola formula. So we're going to do 25.6 out of the book, and we're going to Parabola Formula. Okay, so we're going to do the parabola formula. Alright, so let me get the variables out of the book here. Flip to the page. Alright, so 25.6 is this one right here. So I'm going to be writing all these variables down. So I'm not going to leave the book up there. People that are listening at it. Okay, so we always start with what we know. So known. And in the book it gives us L, and that is equal to 255.00. Oh, sorry, 455.00. Okay. They give us G1, and that is a positive 2.00%. Okay. They also give us G2, and that's a negative 1.50%. They give us the VPI, and that station is 78 plus 60. And then they also give us Y VPI. So anytime we talk Y values, we're talking elevations. Okay. So Y VPI is 7855.35. Okay. So that's our known. All right. Based on this information, I can draw my curve. Okay. I'm going to draw my vertical curve. I'm not going to do it to scale on here. In your guys' assignments, you have to do it to scale. So. Okay. Yeah. Okay, so I know that because of G1 that it's a positive, so I'm heading in a positive direction. Okay, so G1 is a 2%, and then G2 is heading in a negative percentage. Okay. So my tangents look similar to like this, and then I'm just going to draw a curve in there to best fit it in. Okay, so I'm going to put in my components of the curve in here. So I have my BVC here, my EVC, my PVI, which is here, or VPI, and then I'm going to populate the information I know. So L is 455. Okay. PVI has some information here. Its station is 78 plus 60, and the elevation is 55.60. Jeez, I'm looking at the station here. 55.35, sorry. So that's the elevation. So I know the PVI, elevation, station, and I can populate my grades on there. So G1 is a 2.00%. G2 is a negative 1.50%. All right, so I just filled out all the information on my curve that I drew. So for you guys, when you do the homework, you're going to actually draw this to scale. Okay? Cool. All right, so let's look at the formula first. So we're going to add the formula in here. Formula is y equals y BVC plus G1 times x plus r over 2 times x squared. Okay, so we're going to go ahead and tackle that formula here in a second. Now, let's work on the unknown. Right? So what is the unknown? So the first thing that you want to do when you start going about this and trying to solve the stuff that you do not know, always start with the easiest thing first. So the easiest thing to do first is solve the station for BVC and EVC. So we're going to solve the station for BVC first. So BVC is equal to the PVI station minus L over 2. Okay? So my PVI station, or VPI station, they're synonymous, is 7, 8 plus 6, 0 minus L, so 455, divided by 2. So our BVC station is what? Say it again. 76 plus 32.5. Okay. 76 plus 32.50. Okay, so that is our BVC station there. All right. Now we can solve EVC next. So EVC is equal to the PVI plus L over 2. Okay, or it can be the EVC is equal to BVC plus L. Okay, so either way. Yeah, so our EVC, I'm going to do this way, is the BVC, 76 plus 32.50 plus 455. And that should equal what?
Plus
80 plus 87.50. Okay, so that's, we just solved our stations. So now we know where the beginning and ending of the curve is. Okay? Those are the first most important things to do. The next thing we're going to want to do is figure out our YBVC. Okay, so we're going to use this formula here for YBVC. So our YBVC equals this formula here. Actually, you know what? No, YBVC, we don't have to do that formula. Okay, YBVC is this formula here. So it's YVPI minus G2, oh sorry, G1, we're in G1 there. G1 times L over 2, okay? So basically all we're doing is we're figuring out the grade down to this one at that distance. So essentially all we're doing there, okay? So at half the distance of L. So I'm going to have 7855.35. So that is the Y PVI, which is here. And then minus G1. Okay, but G1 in this case is going to be in its decimal form. That's important. So 0.02. We're in a decimal form for G1 here now. Okay, times 455.00 over 2. All right, and that's going to equal what for an elevation for YBVC?
7859.90.
78. You went the wrong way. You added instead of subtracted.
78.50.
What? I literally have a minus sign.
80. Okay.
Wait, is that? Oh, okay, never mind. I see why I did wrong.
7850.80.
I thought it was supposed to be a negative percent.
Oh, yeah, it's
When
positive
you said
percent.
minus,
Yeah. All right, so now the next thing we could do is we're going to find out y EVC next. So y EVC is equal to y dpi minus G2 times L over 2. Okay. That equals 755.35 minus, so I'm dropping the sign on there because we're going to be going negative anyway, we're subtracting it here. So in essence, for the G2 times 455.00 over 2. So the elevation, or EVC, or Y EVC elevation at the EVC is?
So why are you dropping the negative?
Dropping the negative because I'm in the formula I'm already subtracting.
Yes.
I don't want to add because you have to look at the direction you're going, right? We're going in the negative direction.
Okay.
So the crest of the curve is lower than
Then the PVI.
the PVI, or than the EVC. The crest of the curve is higher than the EVC, I mean. So we take that sign away when
So
we're
if
doing this
it
part of the
goes
formula.
The other way.
If it was going
then
the
it
other
would
way,
be
then we would
add it.
add it.
Okay.
Yeah.
So it just depends on the relative position of
Yeah, it
the
depends on if it's a
crest
sag
of the
curve
EVC.
or a crest curve, which way you're going with that. So we're doing a crest curve here. We're going to do an example of a sag curve here in a little bit. So. So what do we have for Y EVC?
Well, I guess it would have to be a non-one. Look which way it's going. G2.
Anybody have the elevation?
78.51.94.
7851.94. 7851.94. All right, so now we're going to talk about
The feet?
one more formula that I haven't put up on the board yet,
Could be meters.
and that's the rate of change formula here. Okay? This rate of change formula. It's the next thing we have to figure out. It's one of our unknowns. Okay? So rate of change formula is R equals G2 minus G1 over L, and L is in stations. Okay? So R, we're looking for, our G2 is a negative 1.5 minus G1, which is a 2.0, divided by number of stations, L in stations, 4.55. So basically we're just taking 455 and divided by 100, because stationing is by 100-foot increments. Okay? So that's why I came up with 4.55 here. I took 455 divided by 100 to make it into into actual stations itself. Okay, and then that number comes out to be negative 0.769. Okay, that's an important number once we get into the tabular format.
Oh.
What is it? Shoot. Did you divide it by? I'm going to do it one more time. 1.5. 2. I got a negative 0.769230769231.
So this one you keep
I
at.
did subtract first, so did,
Yeah.
did,
Yeah, you do keep the percentage, but then you have to transfer the L into a station.
So what if I would have changed it to? Oh, I'm gonna try that.
Okay, so that's R. All right, now the next step is making a tabular format of this equation here, okay? Because it'll help us discover what we're doing in a step-by-step basis. Okay, so I'm going to move up here so we can make our tabular format. All right. Just using the grid lines on the engineering paper here. Okay, so for the top one, or for what we're going to do is we're going to label this across, all right? And basically what we're trying to do with this formula is find elevations at each whole station. Is what we're trying to do. That's why we're trying to find y. That's what y is an elevation. Okay, so I'm going to put the first thing here as a station. The second thing I'm going to do x in stations. Okay, x in stations. And then I'm going to do g1 times x in the next one. Then r over 2 times x squared. So if you see, we have the components of the formula in here, okay? And we're going to be using YBBC. The first thing, I want to put the curve elevation in there too. Okay. All right, so the first one we know. We want to populate the first one, and that's the BBC station first. So I'm going to put BBC on the side here. Okay, our BBC station that we figured out was 76 plus 32.50. So 76 plus 32.50. Okay? Now I want to go to whole stations after that. So I'm just going to go all the way out to, for whole stations, all the way out to our EBC station. So I'm going to go 77 plus 00, 78 plus 00, 79, 80, and then we have our EBC at 80 plus 87.50. Okay? So I just did our whole stations in between and then ended at the partial station of EBC. All right, so let's populate BBC because we have all of this information figured out for BBC already. It's pretty simple. So BBC is our starting station. So X in stations is 0. Okay? X in the change of stations is 0. We're not changing any stations at BBC. G1X is 0 because X is 0 here, so we can't take 0 times something, it gives us 0. Right? And the same thing here. X is 0 here in the formula, so it's 0 there. And we already figured out our elevation for YBBC, and it was 7850.80. Okay? So that one's all set. Now we also figured out EBC, but I'm not going to do that one until we figure it out in the formula. Okay, I'm not going to populate that because that's going to be a check for us as to whether we did it right. Okay. All right, so the next step then is to figure out what X is. And this is actually a pretty simple thing to do. For X, yeah, that's bad. Let me see if I can get that to, oh, that doesn't help.
It's from that way.
All right, well anyway, you'll be able to see when it pops in there. I'll try to tip it like that, okay? So basically all we're doing is subtracting stations. So I have 7,700, okay, is the station right here. And I'm going to subtract the 7632.50. Okay, I'm going to subtract those, and it gives us that answer. Now we have to turn that into stations, right? That's the whole footage difference between. And for x, we're in stations. So my stations for this are going to be 0.675. That's my distance in stations, essentially. It's not a whole station, less than 100 feet. So I put it in its decimal form. 100 feet would be one station. That'd be number one. Okay? Okay, so now we figured that out, it's going to be pretty easy to do our stations from there on out. Right? So basically, I'm transferring 100 feet between here and there. But really, this x is the number of stations from the original station. Okay? So x here at 78 plus 00 is actually 1.675. So all we're doing is adding 100 to this first one. Right? Because we're just moving another 100 feet. That's all we're doing. So then 79 is going to be 2.675. 3.675, and then you got to be careful with this last one. The last one, this is a check for us to make sure we figured out our stations right. This last one, if I take my last station, my EVC station, 80, 87.50, and then subtract 76, 32.50, I get 455. I don't know, I must have fingered a number or something in there that didn't give me actually 455, but it is 455, okay? So my last station here is 4.55. That is a check for us to see if we did our math right. Because if I change this in, right now it's changed into stations, but the whole distance of L is 455 feet. So this in stations is 4.55. So that's a check. We checked okay there, okay?
Howard, can you redo that?
This? Okay, so I just took the stations. So I took this EVC station that we calculated above here. So 8087.5, and then minus the BVC, 7632.50 minus. And that gives me the 455, as you can see on the calculator. Gives me 455, and that is actually what L is, so that's a check. But now we want to turn that into stations, and that's why I wrote 4.55. Okay? Now, there are examples when you guys are doing your homework that I'm going to have you do half stations. Okay? It's no different than doing it as full stations.
Just 50 feet.
Yeah, that's all it is, 50 feet. So it's just a little bit different number you're going to end up with. Okay? All right, so now we're going to figure out G1x. Well, I know G1x here, so I just figured out x. G1 is our grade, 2.00, okay? So we can figure out this number based on that. So if I put a calculator up there again, G1 is a 2% times the 6.75. So 0.675. And I'm going to multiply those. So I get 1.35. Okay? So here, 1.35. And then so on. We'll do the same thing all the way down. So I have 2 is my G1, and then times 1.675 gives me 3.35. If you can see, all of a sudden we have a repeating pattern here. If I do my G1 again times my X, 2.675, it's 5.35. I can guess that this one's going to be 7.35, and then the very last one, 2 times 4.55 is 9.10. Okay, so 9.10. All right, so we figured that one out. Okay, I'm going to clear that. Now we're going to go about doing r divided by 2 times x squared. So we figured out r here, right? This is a constant now. So I have a 0.769, a negative, and I'm dividing it by 2, and then I'm timesing it by x squared. So 0.675, so just timesing it by itself is squaring it. And then I times it by what I got for r over 2. And it gives me a negative 175. So negative 0.175. Okay? So we just continue that all the way down. So why don't you guys give me the rest of them then? I want r divided by 2 times x squared for 78 plus 00, 79 plus 00, 80, and 80 plus 87.5. So if you guys can give me those, that'd be great. Whenever you know it, just shout it.
Negative 1.079.
Negative 1.079.
Negative 2.751.
Negative 2.
Negative 5.193.
Negative 5.193.
Negative 7.96.
So this one here, though, did you round up once you got there's a significant digit that was rounded up?
I think
5.194 should it be? Should you round up?
I got 93.
93? Okay. Okay. And then this one here,
7.963.
7.963.
Oh, yeah, it's rounded up. It was 92.
Okay.
92.
All right.
119.
So now we can figure out our elevations here. Okay, pretty simple. So all we're going to do is take our curve elevation of our BVC, and we're going to take and add this. That's what we're going to do. Okay, add the negative. Well, hang on, no, that's not exactly true. So we're going to actually put this through like we're doing the formula. So it's going to be it's going to be all of this together. So it's going to be this and this plus that. So grab this. So we have 7850.80. Okay. And we have our R2X. So 0.175, that's a negative. And then we have our G1X, 1.35. Okay, so we're going to add, and then add, and that's what we get. Okay? So we're basically adding these to that. So it's going to be 7851.975. Okay? So now be cognizant of this though, we're always using YBVC. We're not using the previous elevation. So when I go to do the elevation for 78 plus 00, I add these two together and then add it to the BVC elevation, not the previous elevation. Okay? So I have to put in the BVC elevation. I'm going to stack it a couple times in here. And then I'm going to take and do this. 0.79 negative 3.35 plus. Okay, so the next elevation is 7853.071. Okay, you guys give me the rest of them. Give me 79, 80, and 80 plus 87.50. 78.40. I'll round up.
Just the next one.
They use this number plus this number, preserve the signs. Take this number plus this number, add it to this, and then do that. But you always add it to that. For the first one, yeah. That's it.
7852.957.
Yep, 7852.957. Now pay attention to that. Notice that all of a sudden we're going down, right? Well, that makes sense because we're figuring out elevations on a curve. So now all of a sudden we're heading back down. So we hit the high point in here somewhere, right around in 78, between 78 and 79 station. So that's the high point in there somewhere. Or it could be between 80 and 90, or 79, really. Somewhere in there, in this area it went down. So what's the EVC?
78, 90, or 78, 51, 927.
7851.94.
Can't just round it.
Well, the thing is, we're going to round it anyway because this is our check, okay? So this checks with that. We figured that elevation out already once. So they check. So if this is rounded, it's going to be off in the thousands compared to this one. So
we can't measure that.
yeah, you can't measure that close. That's right. Very good, Scott. Okay, so
I don't know the DOT.
one more thing we want to figure out on this, okay? So, and this is a problem that is on the FS exam, I guarantee it. It's a high point calculation. All right, so what's the high point of this curve, this vertical curve, or the low point? Well, in this case, this is a sag curve, right? This is a crest curve. Okay, so it's a crest curve. So we're looking for a high point. If it was a sag curve, we're going to be looking for a low point. Okay, so the high point formula is, or low point formula, is negative G1 divided by R. Okay, so let's figure that out. G1 over R. G1 is a negative 2.00 over R, which we already figured out, negative 0.769, and that equals what? Now, the high point is in stations, okay? Right now we're figuring out stations. This isn't an elevation. This is going to give us stations to where that high point exists. Okay, so if I go 2 negative divided by 0.769 negative, it's 2.6007. Okay, I'm going to carry out significant digits on this one for a reason, okay? So this is in stations, 2.6007. Carried out to the 10,000th there. Okay, so if I do my high point here, I know that if I go from the BBC and I add this number of stations, so this is my stations here, 2.6007, that's my X value. If I add that to here, make it stations and add it there, so 260.07. 260.07, and I'm going to add it to my BVC station, 7632.50. Okay, that's the station where the high point exists, or where it comes into play. So it's at 78 plus 92.5. 0.58. I'm going to round up on that one. Okay, so that is the high point of our crest curve.
Howard,
Yes.
so you took the 3.6 or 7 times 76.
Plus a 7. And that gave me 7. So this is times 100 because this is in stations. Okay? And then I times it by 100, so that way it was in feet, and added it to my station to get that. Okay? All right. So now, this will be all of this video. We're going to figure out G1x, r divided by 2 times x squared, and that'll give us the curve elevation for where the high point exists. So, G1x, let's figure that one out now. Okay, G1x, G1 is 2, and x was the number of stations here, so 2.6007, and we're going to times those together, and that gives us 5.2014. Okay. Now I'm going to figure out my r over 2 times x squared. So r is the rate of change. It's 0.769 negative. Okay. And then I'm going to take it, divide it by 2, times it by x squared. So x squared is right here, 2.6007. Times it again, and we have a negative 2.6006. Okay? Now we can figure out elevation. So I'm going to take this, the BBC elevation, 7850 plus 80, enter. So we always start with that. And then I'm going to take and put in the negative 2.6006, add it to it, and then I'm going to add the G1x, which is 5.2014, add that, and our high point elevation is 7853.40. 1. Okay? So it's pretty much, the high point is pretty much 79 plus 00, but this is the exact high point of that vertical curve. Okay? Questions?
Yes.
Shoot.
That high point formula,
Yeah.
that negative G1,
Yeah.
that's there if it works. for
Always
the-
constant.
say
Yeah, so if it's a sag, that because
It'll
if
turn
it's a
it
sag
positive.
curve, it'll turn it a positive. Yes. Okay. So yeah, when we do the low point, it's the same thing. You just call it high point on a crest curve, low point on a sag curve. Okay. We'll do a crest curve or a sag curve here also. I'm gonna make up a bunch of variables because I don't have one already made. But why not? So any questions beyond that? Okay. Okay, go ahead. So let's be posted on Blackboard. I'm recording it right now. So, okay. So that was 25.6 out of the book. Okay. We could tackle 25.7 out of the book. That's a. Never mind. That's a crest. No, that's a sag curve. Double sag. So, all right. I'll just make one up quick for a sag curve. Okay, so now we're going to talk about a sag curve. Okay. No particular one on this. So I'll give you the same knowns again. Not the same, but some different ones. So L, we're going to have at 800. So that's the length of our curve is 800. G1 is going to be a negative 4.00%. G2 is going to be a positive 2.00%. Okay? So that tells us it's a sag, or sag curve. The VPI is going to be at 60 plus 00. And the Y VPI, the elevation at VPI, is 500.00. I like round numbers, as you can see. Just makes math easier. Okay, so let's draw this bugger up. Okay, so I know it's a crest curve because of my grades. I'm going negative here and a positive in the G2. So my back tangent is a negative, my forward tangent is a positive. So it's a crest curve. Okay, and we're going to do one of these numbers, put it in there. I'm going to label my components just so that way I can get it straight. VPI, BVC, EVC, L is 800. Okay, my G1 is a negative. G2 is a positive 2.00%. Okay, I think I labeled everything. Probably should put in the station here, 60 plus 00, and the elevation is 500 feet. Okay, I'm sharpen my pencil quick. Run out of lead. So, a good question, James. So the VPI elevation here, this 500, is exactly right here. Okay, it's at this point, so it doesn't actually occur on the road. Okay, so when you're looking at this elevation, know that it's at the intersection of the tangents, essentially. Okay, it's not actually on the road surface. The road surface is this here, say, or the vertical curve surface is right there. So this elevation really is just the intersection of the two tangents. Okay? So yeah, on this one it's under the road. Yeah, somewhere below the road somewhere. On a crest curve, it's above the road somewhere.
In the phragmites.
Up in the phragmites, yes. Okay, so let's go with our unknown here then. So we'll figure all those out. So we want to find the BVC station first, and that's PVI minus L over 2. Okay? So can anybody give me what that station is? L is 800. What is the station? 56 plus 0, 0. Okay? Good round numbers. Let's look at our EVC station. And I'm going to do it the BVC plus L, and that equals 6,400. 64 plus 0, 0, right? So the BVC, which is this, plus L, which is 800. So it gives us 6,400. Okay. All right, so let's find YBVC now. So YBVC is a very important thing to find because that's the building block for the rest of our whole formula. So that's one of the very first things we always find is YVBC. And that is YVPI minus G1 times L over 2. Okay? So YVPI is 500 minus G1, oh, it's a negative 4.00. But remember, we turn this into a decimal form. Okay, so I'm actually going to change that to decimal form. So it's a negative 0.04 times L. L is 800 over 2. Okay, so what do we get there? 500, and we have 0.04, and it's a negative. And then 400 times minus. Okay, I get 516. That's our elevation here, 516. Does that make sense? Right? We're at 500 here at the VPI. We should be above it. So we're at 516. Okay, so it makes good sense. All right, let's find the YEVC. We have our YVPI minus G2 times L over 2. 500 minus, we have a 2% there, so I'm going to put that in decimal form, times L over 2. That equals what? In this one, because we're in a sag curve, we're actually adding that. Okay? We're adding that because we're in a sag curve. If I subtracted, I'd be below the DPI, so I know that that'd have to be added. Okay? 508.00. Now that makes sense. Now, if you look at this, my grade here is double the grade here, right? Well, look at the change. Okay? So I added 16 to this. Well, that's double the grade. Well, if I go here, it's half the grade as the first one, and it's half the amount of elevation we added to it. That's another little check when you're looking at these. You can tell, you can vet it, you know. So there's visual cues to this when you're doing it, if you went the wrong way or not. Okay, formula might change some of the signs in the formula, but what you just have to be smart about looking at how the sign is changing for you, okay, and how it's actually applied in the curve. That's why a lot of times I draw these out. I'm a visual person, so I need to draw it out. When I draw it out, then I can reason my way through it. So we'll go about that. All right, so let's figure out R. R equals G2 minus G1 over L in stations. Okay, so that means we have a G2 is a 2.00 minus a negative 4.00 over L, and that's in stations, so it's 8. Okay, let's figure that one out. So we're subtracting a negative, so it's actually going to be adding it. So it's 6 divided by 8. Okay, I got 0.75. Anybody else get that?
Yeah.
For R? Okay. Let's go ahead and make our table then. Together our table here. And we have the station, the X in stations, G1 times X, then R over 2 times X squared, and then we have our elevation. Okay? So we always start with BBC because we already figured all that out. And the station at BBC is 56 plus 0, 0. We know that it's zeros all the way across here because this is our beginning station. So our elevation is what we figured it out to be, 516.00. Okay? Now we're going to go whole stations all the way out to the EVC station, which was 64 plus 0, 0. Okay, so I'm going to go 57 plus 0, 0, 58 plus 0, 0, 59, 60, 61, 62, 63, and 64, which is our EVC. Okay? All right, so who can tell me what x is for 57 plus 0, 0? What's x for 57 plus 0, 0? This is a really simple one. I should have made it a little bit harder. Okay, it's 1, right? It's one station. We changed 100 feet from here to here. So that's 1. Okay, from here to here, how many stations did we change? 2. 3, 4, 5, 6, 7, 8, right? That comes out right because 8 times 100 equals our 800 foot L here. Okay? Now we're in stations. Okay, let's figure out G1X for here. G1X for here. G1 is a negative 4%. So 1 times 4, negative 4.00. 2 times 4, negative 8.00. Negative 12.00. Negative 16.00. Negative 20. (24) that's 0, 0. Negative 28, 0, 0, and negative 32.00. Okay? So we got those figured out. G1X. Okay, so we figured out R, we know what R is, times X squared. Okay, so what is R divided by 2 times 6 squared for 57 plus 0, 0? Say that again.
Negative 0.375.
For 43.75 or 4.375?
No, it's a positive. There's no 4 on it.
Oh,
It's also a positive number.
okay.
0.375.
0.375. Why is that a positive number?
Because your R is positive.
It's a safety group.
And all the
R is positive and X is positive, right? So there's no negative there. In the last example, this was a negative number over in here. Okay? All right, so give me the rest of them. So 58 plus 0, 0. Let's speak up so I can hear it. 1.50.
3.375.
3.375.
6.00.
0.00. 9.375. If you pay attention, there's a pattern happening here. What was it? 13.50. The next one should be 16.375, right? 16.375. And then the last one is 18.
No, it's 18.375. Above. The last one.
18.375.
No,
Oh. Oh boy. Okay, so not 16, it's 18.375. And the last one is? 24. Thank you. Hard one, I'm not using my calculator. Okay. I was just checking to make sure you guys are paying attention. Thank you. Appreciate it. Okay. All right, so let's figure out our elevations. What's the elevation at 57 plus 0, 0? This plus that. 512.075. Okay. Anybody concur with that? Okay. 0.075 or point?
I mean, that's what I got.
516. All right. You're making me do it. Yeah. I was gonna say that didn't look right. 512.375. There we go. All right. How about the other ones? Next one's gonna be basically 516 minus 8. Right? Minus 8. So it's 508 plus 1.5. So it's gonna be 509.50. Right? No one's doing the calculator. I love it. Did you subtract this one?
No, I was doing the next one.
Oh, next one. 507.375. Okay, great. Okay, 60 plus 0, 0. This is a 0. $506.00. That one's actually an easy one. $505 point what? 50. Okay, so we must have hit our low point here somewhere. If you look, it's right around 61 plus 0, 0. We hit our low point. 63 plus 0, 0. 506.375. And then EVC, this is our check. So it's basically plus 8. Or minus 8, 508 plus our 0.00. Okay, it checks with that. We're good. Okay? All right, let's find our calculation is the high point calculation. Low point is equal to negative G1 over R. So negative G1 is it's a negative, so it's a positive. 0.00 divided by R, 0.75. So if I take 4 divided by 0.75, I get 5.3333 repeating. Okay, it's repeating. So that's in stations. Remember, this is in stations. So if I look at that, so if I go up here, low point, and I add the 5.3333, if I add 533.33 to my BBC, it's going to give me my station. So it's 61 plus 33.33 is the low point station. Let's find the elevation of that now. So we're going to have to go through and do this all over again. Okay. So our G1x, so G1 is -4 times x. So this is a -21.3333. Okay. And then we need r times G1x. So our r divided by 2 times x squared, sorry. So r 0.75 divided by 2 times x squared, 5.333. So what do you guys get there? It's 10.6665, I guess. All right. So what is our elevation for our low point then?
Oh.
505.23.
505.333. So that is our low point. So if we look, it's actually, that low point is actually occurring at station-wise between these 2 points. Okay? That's where that low point is occurring, right there. All right, so all I'm going to cover today for this, because I don't want to confuse you with the next one. We just went through tabular format here. We're going to be jumping into tabular format with the other one on Tuesday. So I'm going to post this on Blackboard so you have it. Okay, these are the formulas you want to make sure you commit to memory, because on our test when we do it, these are going to be there. I'm not giving them to you.
What if we bring them?
Can't use them.